What happens when an object from the depths of interstellar space begins to behave in ways no scientist expected? Stay until the end, because what is happening in our sky could forever change the way we understand the cosmos. Just a few weeks ago, a telescope located in the heart of Mexico City captured something extraordinary. Something that has astronomers around the world awake at night, searching for answers that seem to slip through their fingers like fine sand.
Friends, have you ever thrown a stone into the air and expected it to change course on its own? Because that, in essence, is what we are witnessing with this cosmic visitor called 3I Atlas. And I know it sounds impossible, I know it seems like something out of a science fiction movie, but the data is there, the images don't lie. What will happen when this object reaches the vicinity of Jupiter in 3 years? Will it be coincidence, or are we facing something that will rewrite the astronomy books forever?
The Comet 3I Atlas is not an ordinary visitor. It was not born in our solar system. It did not form in the Oort cloud or in the Kuiper belt. This object traveled distances that the human mind can barely conceive, crossing the void between the stars for millions, perhaps billions of years, until it finally arrived in our cosmic neighborhood. And from the moment it was detected, it began to show behaviors that defy everything we thought we knew about comets. The most recent images, captured by a team of astronomers working in Mexico City, revealed something that left the scientific community in a state close to amazement. The trajectory of this comet, according to the most precise calculations available, experienced an adjustment. Not a chaotic deviation caused by random forces, not a casual push from the solar wind, but a precise change, almost millimetric in astronomical terms, that placed it on a direct encounter route with Jupiter's Hill radius. To understand the magnitude of this finding, first you must understand what exactly the Hill radius is. Imagine an invisible zone around any massive planet, a subtle frontier where the gravity of that world begins to dominate over that of the Sun. It's like its own territory, a gravitational kingdom that separates the influence of a planet from the influence of our star. Jupiter, being the giant of our system, possesses an enormous Hill radius, extending more than 53 million kilometers in all directions, and 3I Atlas, after that mysterious adjustment in its trajectory, is heading exactly toward that edge. Not near it, not in its general proximity, but exactly toward it. The precision is of the type that makes astronomers stop what they're doing, review their calculations 2 and 3 times, and then look for errors that simply aren't there. But here comes the part that truly keeps those who study these phenomena awake at night. That adjustment didn't occur when we could observe it. It happened when the comet was behind the Sun, completely invisible from Earth, out of reach of any terrestrial or space telescope. When it finally reappeared in our field of vision and scientists updated their orbital models, they discovered that something, whatever it was, had pushed the comet just enough to radically change its destiny. The odds of this happening by pure chance are astronomically low. We're talking about 1 in a billion, perhaps worse. It's like throwing a dart from 100 meters away, blindfolded, in the middle of a windstorm, and still hitting right in the center of the target. That is exactly what this interstellar visitor has just accomplished.
Do you realize what this means, friends? We thought a comet was simply a ball of ice drifting, following the laws of gravity like any other object in space. But 3I Atlas is telling us that maybe it's not that simple. What type of natural force can produce that level of precision? Is there something we're not seeing, something our instruments cannot detect? I promise you that the further we advance in this story, the more fascinating it gets.
When a celestial object changes course unexpectedly, scientists look for explanations within the framework of known physics. The first candidate, the most obvious and studied, is outgassing. Comets are composed mainly of ice, dust, and volatile compounds that sublimate when they approach the Sun. Those jets of gas act like small rocket engines, pushing the comet in directions that may seem unpredictable, but follow identifiable patterns. It's a well-documented phenomenon, observed in dozens of comets over decades of study. But here is the fundamental problem with that explanation. Outgassing produces chaotic pushes, not precise adjustments. It's like trying to park a car by blowing on it with an industrial fan. You could move it, certainly, but you would never place it perfectly in the designated space, aligned to the millimeter with the lines painted on the ground. And yet, that is exactly what appears to have happened with 3I Atlas. The push was of the exact magnitude, at the exact moment, to place it on a trajectory that will culminate in March of the year 2026, with a close encounter at Jupiter's gravitational limit. It's the type of coincidence that makes even the most skeptical scientists begin to scratch their heads with genuine perplexity. The images captured from Mexico City also reveal another intriguing element, something that adds an additional layer of mystery to this cosmic enigma. 3I Atlas not only changed its course inexplicably, it is also exhibiting a completely anomalous tail structure that defies established models. Comets, as many know, develop spectacular tails when they approach the sun. Solar radiation and stellar wind push dust and gas away from the nucleus, creating those luminous trails that have fascinated humanity since time immemorial. Our ancestors saw them as omens, as divine messages written in the firmament. Today we know they are perfectly natural physical phenomena, the result of the interaction between cometary material and the energy of our star. But 3I Atlas has something that very few comets show: an anti-tail, a tail that points toward the sun, not away from it. This phenomenon, although rare, is not completely unknown in cometary astronomy. It occurs when heavy particles remain suspended along the comet's orbit, and from a certain observation angle, they appear to form a tail that defies apparent logic. It's a perspective effect, nothing more. Or at least, that's what it should be.
But here comes what has me truly fascinated, friends. The anti-tail of 3I Atlas is too narrow, too defined, too stable. Do you know what it looks like? It looks as if someone had drawn a straight line with a laser through millions of kilometers of empty space. And that, according to the physical models we have, should not be possible. Are you starting to understand why this object has everyone so unsettled?
When a comet releases dust into space, that dust should disperse in a predictable manner. The sun's gravity, the constant pressure of solar radiation, the small gravitational perturbations caused by the planets, all contribute to the particles spreading in a broad and diffuse pattern over time. It's basic physics, celestial mechanics that we have understood and used to predict the behavior of countless objects for more than 3 centuries. But the anti-tail of 3I Atlas does not behave that way. It looks ordered. It looks intentional. It looks as if something were keeping those particles in perfect formation across distances that defy human imagination. And that raises a deeply uncomfortable question for the scientific community. What natural force can maintain such a precise structure across such vast scales? Astronomers have proposed various theories to try to explain this anomaly. Perhaps the composition of the comet is completely unusual, with types of ice that sublimate in ways our models do not yet correctly capture. Perhaps there are magnetic fields involved, electromagnetic interactions between the cometary dust and the solar wind that our equations still don't describe with sufficient precision. Perhaps the internal structure of the nucleus is so irregular, so different from any comet we have studied, that it produces perfectly directional gas jets that create apparently artificial patterns, but that actually obey natural processes we simply don't understand. All of those are possible explanations. Scientists are working day and night to test them, using every available piece of data, every captured image, every spectroscopic measurement. But here is the fundamental problem: none of those explanations fits perfectly with all the observations. Every time it seems that a theory works, a new detail appears that doesn't fit, a piece of the puzzle that simply doesn't match with the rest. The distribution of dust around 3I Atlas presents another mystery that has specialists perplexed. In a typical comet, we expect to see a clear separation between fine particles and coarse particles. Fine dust, being light, is quickly pushed away from the nucleus by the pressure of solar radiation. Coarse dust, being heavier, remains closer to the original orbital trajectory. Over time, this separation becomes very evident in observations, but in 3I Atlas, this separation is not as clear as it should be. There are regions where fine dust and coarse dust appear mixed homogeneously, as if they had been released at the same time from the same region of the nucleus, but then behaved in completely different ways than expected. It's a pattern that defies our models of cometary dust emission in fundamental ways.
And when I say it doesn't fit, friends, I'm not talking about small discrepancies that we can adjust with a bit of advanced mathematics. I'm talking about differences that force us to reconsider our most basic assumptions about how these objects work. Could it be that 3I Atlas is made of materials we have never seen before? Does it come from an environment so different from ours that its physical processes bear no resemblance to what we know? Think about it for a moment.
That possibility is very real and deserves serious consideration. 3I Atlas is an interstellar object, which means it formed somewhere completely outside our solar system, perhaps around a very different star from the Sun, a cold red dwarf or a blazing blue giant. Perhaps in a region of the galaxy where the conditions of temperature, pressure, and chemical composition were radically different from those that existed in the primordial nebula that gave rise to our own cosmic neighborhood. If that is the case, then the comet could contain types of ice we have never had the opportunity to study, organic compounds that don't exist on Earth or in any local asteroid or comet, crystalline structures that sublimate in completely unexpected ways when heated by the light of our star. All of that could explain, at least in part, why the behavior of 3I Atlas is so puzzling for our current models. But even accepting those possibilities, we still have the problem of precision. We still have to explain how a supposedly natural object could adjust its trajectory with such exactitude that it will end up passing through Jupiter's Hill radius in the year 2026. And that, honestly, is the hardest part to accept. Not because it's physically impossible, but because it requires such a specific, statistically improbable combination of factors that it almost seems designed by some intelligence. Jupiter's Hill radius is an immense region of space with a radius of more than 53 million kilometers. It's a zone where the giant planet's gravity begins to dominate over the Sun's gravitational influence. For an object traveling through interstellar space at tremendous speeds, arriving exactly at that edge has no obvious purpose from a purely physical point of view. It's not a place where something special happens naturally, like a breakup from tidal forces or a sudden thermal activation. It's not an orbital resonance point that could capture the object and convert it into a new permanent member of our system. It's simply a gravitational limit, an invisible border in the void of space. And yet, 3I Atlas is heading directly toward it, with a precision that is almost disturbing.
And you know what I constantly wonder, friends? If this were a coincidence, it would be one of the most extraordinary coincidences in the entire history of modern astronomy. But if it's not a coincidence, if there's a reason why this interstellar visitor is heading toward that specific point in space, then we have to ask ourselves what that reason is. Is there something in Jupiter's Hill radius that we're not seeing? Something our instruments don't detect?
The possibility that the comet's trajectory was determined long ago, perhaps even before it entered our solar system, is speculative without a doubt, but it's not completely far-fetched when considered within the appropriate context. If 3I Atlas were an artificial object, or at least an object whose movement had been influenced by some type of technology at some point during its long journey, then its trajectory could have been planned in advance. It could have been specifically designed to perform a flyby of Jupiter, perhaps to use the planet's immense gravity as a gravitational boost, a cosmic slingshot that would accelerate its exit from the solar system toward a new destination among the stars. It's a maneuver that our own space probes have performed dozens of times with resounding success. Voyager 1 and Voyager 2, those ambassadors of humanity now navigating through interstellar space, used Jupiter precisely for that purpose more than 4 decades ago. And if an extraterrestrial civilization wanted to send an exploration probe across the galaxy, using giant planets like Jupiter to adjust trajectories and gain speed, would be a perfectly logical and extremely energy-efficient strategy. Professor Abraham Loeb from Harvard University is one of the most prominent and also most controversial voices in these types of debates. He's not a fringe theorist or an attention-seeking media personality. He's a genuinely respected scientist with hundreds of publications in the world's most prestigious scientific journals. Someone who led Harvard's astronomy department for almost a complete decade. And he has suggested something that makes many of his colleagues feel deeply uncomfortable. Loeb argues that objects like 3I Atlas, and before it, the famous Oumuamua, might not be completely natural in their origin or in their current behavior. He's not categorically claiming they are alien spaceships. He's not saying there are beings from other worlds piloting them through the cosmos. What he's saying, with the caution proper to a rigorous scientist, is that the anomalies we are observing are so significant, so difficult to satisfactorily explain with known physics, that it would be scientifically irresponsible not to consider all possibilities. And that includes, in theory at least, the possibility that we are observing something out of the ordinary. Something that could include, however remote the probability may seem, technology of unknown origin.
Look, friends, I know perfectly well that sounds like science fiction, I know, but if Loeb is asking these questions from Harvard's chair, and more scientists are beginning to admit, even if only in private conversations, that there's something genuinely strange with these interstellar visitors, then maybe we should also keep an open mind. Do you remember Oumuamua, that elongated object that passed by here in the year 2017?
Oumuamua was the first of these visitors to be detected. It appeared without warning in October of the year 2017, captured by the Pan-STARRS telescope located in the volcanic heights of Hawaii. Its name, in Hawaiian language, means approximately messenger from afar arriving first, and it was a truly strange messenger, without the slightest doubt. Its shape was completely unusual for any known cosmic object, elongated like a giant cigar, perhaps 10 times longer than wide, a proportion that had never been observed in any asteroid or comet in our solar system. It showed no visible tail, despite having passed relatively close to the Sun, something unexpected if it really was a traditional comet with ices that should have evaporated. And most puzzling of all, it accelerated as it moved away from our star, as if something invisible were pushing it outward. Astronomers proposed multiple explanations for that anomalous behavior. Outgassing of exotic ices that didn't produce a visible tail, solar radiation pressure acting on an unusually reflective and thin surface, complex thermal effects that no one had previously considered. But no explanation fit perfectly with all available observations. Each theory left some loose end, some unresolved detail, and then, before we could study it more thoroughly with more powerful instruments, Oumuamua disappeared into the darkness of interstellar space, moving away from us at tremendous speeds, leaving us with more questions than answers and a persistent feeling of lost opportunity. And now we have 3I Atlas, another interstellar visitor, another object behaving in ways that defy our established expectations. And this time, the situation is different. This time, the object is not moving away yet. This time, we have years ahead to study it, to observe it with every available instrument, to try to truly understand what is happening.
Will it be enough time to solve the mystery, friends? Or will it leave us with even more questions than we already have? The truth is that no one can know for certain at this moment. But what we do know is that every day that passes, every new image captured, every new measurement taken brings us a little closer to the truth. And that by itself is already extraordinary. Doesn't it seem exciting to you to witness this?
The images obtained from the telescope in Mexico City are contributing crucially to this international scientific effort. The clarity of the photographs, the resolution achieved, the ability to capture fine details in the tails and in the enigmatic anti-tail, All of that is allowing researchers from around the world to build an increasingly complete model of what is really happening with this cosmic visitor. And what they are observing is absolutely fascinating. The tails of 3I Atlas are not static structures as might be expected from a simple chunk of ice and rock adrift. They are constantly evolving, changing shape, developing new structures almost in real time before the astonished eyes of observers. There are specific moments when the anti-tail intensifies dramatically, becoming brighter and more defined than any model predicts. There are moments when new secondary tails seem to sprout from the nucleus, like branches of a cosmic tree growing at impossible speeds. It's as if the comet was somehow alive, breathing, reacting to changing conditions as it travels through our solar system toward its encounter with Jupiter. Normal comets, of course, also show changes in their activity over time. But generally those changes are predictable, clearly correlated with distance from the Sun, with the rotation of the nucleus on its own axis, with the orbital geometry that determines how much solar radiation they receive at each moment. They are changes that our models can anticipate with reasonable precision. With 3I Atlas, the changes seem to occur without a clear reason or identifiable pattern. It's as if the comet were responding to signals we cannot detect with our current instruments, reacting to invisible stimuli that escape our present understanding. One of the aspects that has generated the most intrigue in the scientific community is the object's brightness variability. Astronomers are documenting fluctuations that do not correlate cleanly with the expected rotation of the cometary nucleus. The light curve, that record of how brightness changes over time, shows irregularities that suggest an extremely complex shape of the nucleus, or emission processes that vary in ways our current models cannot satisfactorily reproduce.
It's as if 3I Atlas were playing with us, friends, revealing clues here and there, but never showing the complete picture. And that is precisely the frustrating but also fascinating part of all this. Every time we think we're close to a definitive answer, a new piece of data appears that complicates everything. Will we ever come to understand it completely? That's what we all ask ourselves every night looking at the stars.
There exists a very real possibility that 3I Atlas will move away into interstellar space, leaving us with more questions than certainties, exactly as Oumuamua did before it. Interstellar objects don't remain long in our cosmic neighborhood. They cross the solar system like fleeting visitors, visible for a few months or perhaps some years before disappearing forever into the infinite darkness of space between the stars. Oumuamua was visible for barely a few weeks before becoming too faint to be studied with any terrestrial or space instrument. 3I Atlas, fortunately, is brighter and shows much more intense activity, which provides us with a considerably longer observation window. But even with that advantage, the available time won't last forever. Eventually, the comet will move too far from us. Its light will fade until it becomes an indistinguishable point from the stellar background, and we will be left only with the data we managed to collect during its passage, for better or worse, with all the answers we could obtain and all the questions that remained unresolved. That's why it is so important, so absolutely crucial, that we take advantage of this opportunity while we still have it. That's why telescopes like the one in Mexico City are working tirelessly, day and night, to capture every possible detail of this extraordinary visitor. Because everyone involved knows this could be our only opportunity to study an object like this in decades. If we let this observation window pass without extracting all possible information, we might have to wait years, perhaps decades, maybe even longer, before another interstellar visitor passes close enough to us to be studied with this level of detail. The telescope in Mexico City, with its capacity to capture high-resolution images and its strategic location in the Northern Hemisphere, has become a key participant in this truly global research. The photographs it has produced are being analyzed by scientists from multiple countries and continents, contributing to a collaborative effort that transcends all national and political borders. Because that is precisely what's beautiful about modern astronomy. It's not the exclusive domain of a single country or a single privileged institution. It's a genuinely human effort, shared by researchers from all corners of the planet, driven by that collective curiosity that has defined our species since the first humans looked up and wondered what those bright lights in the night sky were.
And that fills me with hope, friends. In a world that often seems divided by political, cultural, religious differences, science reminds us of something fundamental. We all share the same essential questions. We all look at the same starry sky. We all wonder what's out there in the immensity of the cosmos. And when we work together, when we share our data and our ideas freely, we are capable of achieving truly extraordinary things.
The relationship of 3I Atlas with Jupiter represents another fascinating element of this story that is just beginning to unfold, not only in terms of the object's future trajectory, but also in historical terms that reveal intriguing patterns. Oumuamua, the first known interstellar visitor, also interacted significantly with the gas giant. It used Jupiter's tremendous gravity to accelerate its exit from the solar system, gaining additional speed through a perfectly executed gravitational assist maneuver. And now 3I Atlas appears to be following a remarkably similar path. 2 interstellar visitors detected to date, 2 trajectories that end up passing near Jupiter, 2 objects that defy our expectations in ways that present disturbing parallels. Probably, this is simply a statistical coincidence without greater meaning. Jupiter is, after all, the most massive planet in our solar system by an enormous margin. Its gravitational influence extends across tremendous distances, affecting the orbits of countless objects, both local and visiting. It would be natural to expect that many objects crossing our system would end up interacting with it in one way or another. But there's something in the observed pattern that is deeply intriguing to those who study these phenomena. 2 visitors from distant worlds, 2 encounters with the same giant planet, 2 sets of anomalies that defy conventional explanations. The human mind is naturally inclined to seek patterns, to connect scattered dots, to construct coherent narratives from fragmentary data. And sometimes those perceived patterns are illusions, simple coincidences magnified by our innate tendency to find order in chaos. But other times, those patterns turn out to be the first clues of something genuinely significant, the early signals of a real phenomenon we are just beginning to glimpse. As we approach the anticipated encounter in March of the year 2026, anticipation in the astronomical community continues to grow palpably. That year, 3I Atlas will pass near Jupiter's Hill radius, and scientists eagerly await that encounter to reveal crucial information about the object's true nature.
If the comet shows significant changes in its activity during the flyby, if it develops unexpected new tails, if it experiences additional acceleration we cannot explain with known forces, all of that could provide us with fundamental clues about what is really propelling it. Will there be surprises waiting for us at that moment? Personally, friends, I believe there will be. The universe always finds ways to surprise us when we least expect it.
On the other hand, if the encounter with Jupiter turns out to be calm and without notable incidents, with the comet behaving exactly as standard gravitational models predict, that would also communicate something important to us. It would indicate that perhaps, after all, we are observing natural processes we simply don't completely understand yet, physical phenomena that require new theories but don't transcend the limits of known nature. And that is precisely the beauty of the scientific method. We don't always get answers immediately. Sometimes we must wait patiently, observe with sustained attention, analyze the data with meticulous rigor, and be genuinely willing to change our minds when the evidence requires it. Science is not a set of truths carved in stone. It's a dynamic process of continuous discovery, a permanent conversation between humanity and the universe. There's something profoundly human in this incessant search for understanding. Since our species first looked at the night sky hundreds of thousands of years ago, we have wondered what is truly out there. We have created elaborate myths to explain the stars. We have built religions centered on celestial bodies. We have developed increasingly sophisticated scientific theories to describe the movements of the heavens. All that effort, extended across millennia, represents a continuous attempt to make sense of those bright lights that mysteriously twinkled above our heads every night. And now, thousands of years after those first amazed observers, we have instruments capable of studying those lights with a precision our most visionary ancestors could never have imagined in their boldest dreams. But the fundamental questions remain essentially the same. What is out there in the infinite vastness? Are we truly alone in this immense cosmos? Are there other conscious beings observing the stars from distant planets, wondering the exact same things we wonder every night? 3i Atlas cannot answer all those transcendental questions by itself, but it is providing us with valuable clues. It is demonstrating that the space between the stars is not empty or inert. There are objects traveling through that apparent void, objects with histories stretching back billions of years, objects that may contain information about places and conditions we will never experience directly.
And that, for me personally, is incredibly exciting, friends. To think that a piece of matter formed around a completely different star, in a region of the galaxy we will never visit, is now passing through our cosmic neighborhood so we can study it. It's like receiving a letter from an unknown sender in a language we are just beginning to decipher. Doesn't it seem extraordinary to you to be able to witness something like this in our lifetime?
As the comet continues its inexorable journey through our solar system, each new observation adds an additional layer of complexity to the mystery that surrounds it. Astronomers are documenting brightness variations that don't follow expected patterns. They are identifying fine structures within the tails that suggest multiple emission sources operating simultaneously. They are recording changes in the anti-tail that occur with a speed that is difficult to explain through simple orbital perspective effects. It's as if 3i Atlas was somehow communicating with us indirectly, revealing fragments of information, but never the complete and coherent picture we so yearn for. And that feeling of always being one step from total understanding, of having the answer just out of reach of our extended fingers, is what keeps scientists working tirelessly, night after night. The mystery is not impossible to solve. Nothing in known physics suggests that the observed anomalies are fundamentally inexplicable. But the solution continues to elude the best researchers on the planet, hiding behind each new observation, transforming with each new piece of data incorporated into the analysis. The images from the telescope in Mexico City will continue to be an invaluable source of scientific information in the coming months and years. Mexican astronomers have conclusively demonstrated that with the right instruments and the necessary dedication, it is perfectly possible to contribute significantly to the great mysteries of our time from any point on the planet. 3i Atlas is undoubtedly one of those mysteries, an object that arrived from the unfathomable depths of interstellar space, a visitor that behaves in ways that defy our most solid expectations, a phenomenon that is forcing us to reconsider what we thought we knew about comets, about the physics of space, and perhaps even about our own position in the vast tapestry of the universe, because that is precisely what these interstellar visitors are communicating to us with their mere presence. They are telling us that the universe is bigger, stranger, more wonderful than we ever imagined in our most expansive moments. They are reminding us that despite all our impressive technological advances, despite all our sophisticated telescopes and our elegant mathematical theories, we are still humble apprentices in the infinite school of the cosmos. And every time we think we finally know everything, every time intellectual arrogance threatens to settle comfortably in our minds, something like 3i Atlas appears to remind us gently but firmly that we are just beginning to understand the true nature of reality.
Throughout the coming weeks and months, friends, more data, will continue arriving from observatories around the world. More analyses will be published in scientific journals. More researchers will offer their interpretations of what is really happening up there. And with each new piece of information, the puzzle of 3i Atlas will become a little more complete, a little clearer, a little closer to a definitive answer that may never fully arrive.
It's an invitation to remember that the cosmos is, and always will be, stranger and more wonderful than our finite mind can completely conceive. An invitation to keep alive that spark of childlike wonder we all carry inside, that capacity to marvel at the unknown that defines us as a curious and searching species. The universe owes us no explanations. It's not obligated to be comprehensible or simple or welcoming to our limited cognitive capacities. But despite that, it continues to reveal its secrets to us little by little, fragment by fragment, mystery by mystery. And every time we discover something new, every time we solve an ancient enigma only to find 10 new ones waiting behind it, we grow a little more as a species. We become a little wiser, a little humbler, a little more aware of our true place in the grand scheme of things. 3i Atlas is just the latest chapter of a story that began billions of years ago, when the first star ignited its light in a dark and empty universe. It's a chapter that continues to be written at this precise moment, while you listen to these words, while telescopes point toward the sky, while scientists analyze data and propose theories. And it's a chapter that will continue to unfold long after all of us have departed, when new generations look toward the stars with fresh eyes and open minds, wondering the same things we wonder today, marveling at the same mysteries that keep us awake at night. So let us keep our eyes firmly fixed on the sky. Let us follow the scientific updates with genuine attention. Let us pay attention to the new analyses and discoveries that will emerge in the coming months and years. And let us always remember that in this vast universe full of stars, planets, and mysterious objects traveling between them, we are part of something infinitely greater than ourselves. We are explorers by nature, dreamers by vocation, eternal seekers of cosmic truths we may never fully reach, but will never stop pursuing. And that, at the end of the day, is what makes us truly human.
Friends, before saying goodbye tonight, I want to ask you something from the heart. If this story made you think even a little, if it made you wonder about things you normally don't wonder about, if it made you feel that spark of cosmic wonder we all carry inside waiting to be ignited, I sincerely invite you to subscribe to the channel. There are many more stories like this waiting to be told, many more mysteries of the universe to explore together in the nights to come. I would genuinely love for you to accompany me on that journey of discovery.